A challenge when operating a district heating network on biofuels is that prices vary so much. There can be storm damage, and then biofuel prices drop. Or there can be insecurity in Europe, and then biofuel prices rise. Trying to set a good price for the customer and maintain it can be a huge challenge.
Looking at the European Union today, around 2/3 of district heat supply comes from fossil fuels such as natural gas, coal, and peat. This highlights both the scale of the challenge and the opportunity ahead.
What we see in the future is that district heating networks will diversify, so that both biofuels are used, waste heat from industries is used, solar heat is used, heat pumps are used, and all of this is combined in a seasonal storage, where heat can be stored from summer to winter, so that you continuously generate heat with the cheapest energy source and then store it in the seasonal storage.
During the summer months, when energy consumption is often low, the costs for traditional heating can paradoxically be higher. But there are ways to reduce these costs and optimize energy use year-round.
One thing that few know is that the heat produced in district heating networks is significantly more expensive in the summer than in the winter. And this is because district heating networks usually have a large fixed fuel boiler that is sized for the winter load. And when it then has to run in the summer at only a small fraction of its maximum capacity, it becomes very inefficient. An alternative way to handle it is to buy an additional boiler that uses, for example, pellets. But pellets are a significantly more expensive fuel than wood chips, which are burned in the large fixed fuel boiler. In addition, despite delivering much less energy, you still need high staffing to keep the boilers running. And these factors together mean that the heat delivered to households in the summer can be twice as expensive to produce as heat in the winter.
To solve this challenge, there are several pieces of the puzzle. Solar heating is a proven technology that provides low energy costs and also stable energy prices over a long time. Solar heating also generates the most heat in the summer, when traditional district heating otherwise struggles with high costs. The best result is achieved when solar heating is combined with heat storage, so that the heat generated during the day or in the summer can be stored and then used when it is needed the most. In such a network, it is also profitable to introduce heat pumps that can generate heat when electricity prices are low, or use the last residual heat in the storage to deliver it as usable heat to the customers.
Solutions like these meet the gradually increasing demands for environmental and sustainability standards placed on our society. It is not only climate-friendly and a way to position oneself, but also a smart economic strategy. One way to streamline heat supply is through so-called sector coupling, which broadly involves converting one type of energy into another. One scenario could be to utilize the surplus of low-price electricity with heat pumps, which in turn store the heat in a seasonal storage, which can also store excess heat from industries and solar heat. Such a heat storage can then be used to reduce peak loads on the district heating network during winter and contribute to a stable heat supply.
What determines how long heat can be stored is really how large the heat storage is. And here there's a whole range of different technologies. Everything from small accumulator tanks for hot water, all the way up to large pit storage or rock caverns, where heat can be stored from one entire season to another. Pit storage offers great opportunities to increase profitability in the district heating network. If you have a pit storage, you can disconnect production from usage and therefore produce energy when it is most profitable and use it when it is needed the most. A combined heat and power plant can produce energy when electricity prices are high, and customers can then use the heat when the demand for heat is greatest.
Here at Absolicon, we offer our concentrating solar collector But we have also become experts in helping district heating networks investigate how solar heat can be integrated into different types of district heating networks. So we can conduct studies where we combine solar collectors, electric boilers, and heat storage to see how to achieve the cheapest heat in a district heating network during the summer. We can also help design seasonal storage, where cheap heat can be stored from summer to winter, thus leveling out energy costs and eliminating peaks in district heating production. We have built this type of district heating connected solar heating installations for almost 15 years and have extensive operational experience, which we have now transformed into different simulations where we can take a heat demand in a district heating network and simulate how we would produce and cover that demand with solar heat. And we also have the expertise to show how to build these seasonal storages to store heat from summer to winter, which is suitable for solar heating. But there can also be residual heat from industry or waste incineration that one might be interested in storing from summer to winter. And these pit storages are an extremely cheap way to store heat. These heating systems that Absolicon builds are designed to have a lifespan of many decades. And we have installations from 2011 that are still in full operation. So the system we have developed is adapted for the long life cycles in district heating, where you build a solar collector field and then it just works decade after decade and produces heat. The heat that is produced is free. The only thing you pay for is the investment to build the solar collector field. So the cost of heat in a solar collector field is basically just interest and repayments on the solar collector field. So with cheap financing, the heat becomes significantly cheaper than burning biofuel.
In a Nordic climate, warmth has historically been linked to survival and security, and it is a fundamental condition even today. Sustainable energy solutions are synonymous with the climate-conscious society we live in, and will increasingly influence the investments we make for the future. These are changes that must be made, not only for the climate, but also to ensure a stable and cost-effective energy supply in the long term.